is equal to what? Is it size? No. I want to find out what is the address width. What is the address width? Width of the address. So I can write depth is equal to, correct? Depth is equal to 2 power what? Address underscore width. Or size, or I can call width. Okay. So from this we can calculate what is the depth. Correct. Now let us start modeling the memory. So if you look at the memory, what are the input ports and what are the output ports of the memory? So let us begin once again writing the design file for the memory. So what are the input ports for the memory? So memory input ports are like what? Clock, reset. So today I am going to write like clock reset. Yesterday I showed you that to indicating that what are the ports are input port and output port, we are writing underscore I and underscore 0. So let us write the clock like this: clock, reset. This is input and output. These are input. Then what is another input? Address. Correct. Let us write the address is ADDR. Then I need to write the data, right? Read the data. Read data. W data means write the data. R data means read the data. Then what are other inputs I need? Read and write enable. Shall I use the read and write enable like this? Then what are the other two inputs? To do the handshaking, valid input, then I can ready. If they are ready, so we can do the handshake. So this is the port list of the memory, correct? Then now, so we are using the parameter. So what is the use of the parameter? So parameter is used to customizing the program, right? You can change the width, you can change the depth, you can change the address width. So I am going to declaring the parameters. So what parameter I can use here? This case is width. So let us take width is 16. Okay. Then parameter. What is depth is 32. Let us take depth is 32. Then I need one more parameter. This parameter is for what? Address width. So what is address width of this? For this width and the depth? 5. So there is one more way you can calculate this manually. So you know that depth is equal to 2 power of address width, right? To calculate this, we can use the system task function. That is dollar symbol C log base 2 of depth. So what it will do? If you take you can see here, what is the depth formula is? 2 power, right? 2 power depth. If you take log on both sides, what happens here? If I apply the log on both sides, log of what? Log of depth is equal to what? Log, correct? So log of, I can write this nothing but log of what? 2 power address underscore what? Width. Address underscore width. Now if I write this right hand side equation, this is equal to what? There is a formula we were talking about this. You know that depth is equal to 2 power, correct? Address underscore width. Address underscore width. If I take log on both sides, log of depth is equal to what? Log of 2 power address minus width. Address hyphen width. Right? How I can write this equation? Now this equation I can write what? Address underscore width of what? Log 2. And how to find out the address is address underscore width is equal to what? Address underscore width is equal to what? Log of depth divided by what? Log 2. So this I can write what? Log base 2 of the depth. Correct? So what system task function used to calculate this address width is nothing but I can use this one. Dollar symbol C log of what? Base depth. So what is a C log base 2 is nothing but C log 2 is nothing but what? This is the one. Log base 2 of what? Depth. So depth is 32. What is the address width is nothing but 5. Did you understand? What is a log 32 divided by log 2? Can you calculate? So if I'm taking depth is equal to 32. What is a log? Log 32 divided by log 2 is nothing but what? 5. Did you understand? So to calculate the address width, I can use what? Dollar symbol log 2, C log 2. So this is one of the system task function. I can use what? To find out the address based upon the depth, I can use what? C log 2 of what? Depth. So this is what I'm writing. To find out the address of this. To find out the address width is nothing but what I can use? C log base 2 of what? Depth. Then what are the input ports are here? What are the input ports? Input is nothing but clock and the reset. Then another inputs are, let us write read and write enable is the one input, is a scalar, and then valid input. Then another input is what? Another input is width, correct? So parameter I am declaring as a capital letter. Width minus 1 of what? W data. Then another input is nothing but what? Input is address underscore width. Address underscore width. So this I have declared as a capital case. Address underscore width is equal to what? Width minus 1 colon 0 of what? ADDR address, correct? Then what are the output ports here? What are the output ports is? Output reg of ready is the output. Then output reg of what? I can write width minus 1 colon 0 to 1 is nothing but R data. Read data. So these are the input outputs. Then how to write the memory for this? Declare the data type is integer, correct? Width minus 1 colon to 0 of, let us take array name is memory, and this is nothing but what? Depth minus 1 colon to 0. Let us do end value. Did you understand input and output port declaration here? Now how to model the memory? So this is the parameters I have declared here. So these are the ports I am declared here, input ports, and this is nothing but output ports. This is a memory, array of memory, correct? Array of vector is nothing but what? Memory. So I am taking the array name is what? Mem. This is a vector. This is nothing but what? Depth is nothing but array. Now I need to model the what? Memory, correct? So I can go with what? Always at the rate of what? Pass edge of the clock. Begin. Always at the pass edge of the clock, what I need to do? Let us begin and end here. What I need to do? Always at pass edge of the clock, what I need to do? How we can model the memory? So we are using reset pin. What is the use of the reset pin is? You decide that if my reset is 1, you make all memories to what? Zeros. Make them into the steady state. If reset is 0, then you do perform the operation is whether you can write the data to the memory or you can read the data from the memory. So I can use if, I can use the conditional statement. If my reset is equal to 1, so what I can do? Then my reset is equal to 1. So what I can do? So I want to make my R data is equal to 1. R data is nothing but 1. Read data is equal to 0. Read I should make 0. Then what I need to do? Ready also 1. 0. Then what I need to do? Now I'm making my read data is 0. Write data, ready also 0. Now what I want to do, all this memory address I need to keep what? 0. So what is the depth of this is nothing but 32. Now I should iterate the what? 32. So that I'm using what? For loop. Shall I use the for loop? So I'm using integer I is equal to 0, where I is less than what? What is the depth, right? What is the depth is 32. The memory of 0, memory of 1, memory of 2 up to so on 1. Memory of 31. So depth, then what I can do? I am going to increment the I. Then I am going to, shall I write like this? Memory of what? For all this iteration is I. Memory of I is equal to what I can do? 0. Did you understand this? Now I am using I here so that I need to declare this, right? Integer 1. When my reset is equal to 1, what I am doing, read data is equal to 0. Ready also 0. Both the valid and ready becomes 1. Then we can do the answer. And in this case, I am making reset is equal to 1. R data is 0, so read data is read output is 0, R data is 0. Then for all this memory, M of I I am keeping 1, 0. So how this will be treated M of I? So M of 0, first I became 0, M of 0. So what is the width we are taking for this is nothing but what is width? 15 down to 16, 15 down to 1, 0 means it is 16. So it is getting M of 0 is nothing but what? 0, M of 1 is 0, M of 2 is 0, up to so on, M of 31. M of what? 31. I am using depth here. All this depth I am making what? 0. Then I am going to end this because there are multiple statements to what? My if condition. Now then what I need to do? If this is equal to 1, reset is equal to 1, I am doing this. Memories, I am keeping all my memories to, I am not writing the operation, all my memories I am keeping what? Zeros. And read operation I am doing what? 0 only. Then what I need to do? Else, correct? Else, the else what I need to do? Else means reset becomes what? 0. When reset is 0, what I need to do? Then I should do the write operation and what? Read operation. To do write operation, read operation, first what we need to do? First we need to check the valid and the ready. If my valid is equal to 1, what I want to do? If my valid is equal to, yeah, hello?
Sir, when R data is equal to 0, how about the write data, sir?
Write data, I'm making all memories to 0. My intention is that when my reset is equal to 1,
instead we can take read write enable 0 now, sir.
Yeah, you can take that also. But my intention here, what I'm doing is nothing but when my reset is 1, what I want to do, my memory to what? I should make into the steady state. All the locations of the memory I should keep 0 so that I'm doing this. Okay. Now, if valid is equal to 1, then what I need to check? To do write operation, read operation. I should check the read operation, right? Read operation. I can write the, what is the body of this if I can write? Ready is equal to 1. If ready is equal to 1, now valid is 1, ready is 1. Then what I need to do? Now I should see the enable. Write read enable. If write read enable is 1, I should write the data. write read enable is 0, I should read the data. Now I am going to check here. What I need to check here again, I can write what? A. What is the variable I am using is nothing but WR underscore what? Enable. Write read enable. If this is equal to 1, what I want to do? Write the data. How to write the data? I need to write the data to the what? Memory. So what is this is? Memory of what? Address. Memory of address is equal to what I need to write? W data. Did you understand? When write read enable is equal to 1. Else means what happens here? Write read enable becomes what? 0. When this is 0, what I need to do? R data, read the data, correct? Read the data, what data I need to read? From the memory, right? So this is nothing but memory of what? Address. Did you understand? Now this is closing for what statement? This end is closing for what? This is correct? I need to end. I am using begin here. Then what I need to do? For this begin I need to what? End. So for this else I am going to do what? End. Then what I need to do? I need to do the end for the honest. And if I have done the end here, I am going to remove one end. So this is we have done. This is nothing but modeling the memory. If reset is 1, whatever reading data should be 0. All your memory locations to 1, 0. Reset is 1. When reset is 0, you are checking that valid is equal to 1, ready is equal to 1. If read write enable is equal to 1, then you are writing the data to the memory. If you read write enable, when valid is 1, read is equal to 1. Write read enable is equal to 0, then you are what you are doing? You are reading the memory. Did you understand this? Now let us run for the syntax errors to this first. So this is design file. Okay. Now let us run for the syntax errors. Any syntax errors we have? So there is a unable to bind the wire reg memory valid. I think there is a spelling mistake here. So I should use, what is the valid spelling? VALID. So what is the spelling I am using here is nothing but VAILD. Let us change this. Now this is fine. We are done with the design file. Now you write the test bench to this. Test bench to this. Let us take wtb.v. Let us open this test bench. What is the test bench to this? Shall I modify this only, or I can type line by line? Well, for this memory, let us go line by line, writing the program, then you will be understand. Okay. So first what I need to do, I need to include the file. What is the name of this file is nothing but name.v file. Okay. Then what I can include the what? Tick time scale. Tick time scale. So 1 nanosecond divided by 1 picosecond. Now what I need to do? Module, to write the test module TB. Okay. What are the parameters, sir? Parameter width is equal to what? 16. What is parameter? Parameter depth. Depth is equal to what? The considering is 32. I can write parameter address underscore width. Address underscore width is equal to what? I can write system task function $symbol log base 2 of what? Depth. Did you understand this? What C log base 2 will do? Log of depth divided by log of. If depth is 32, what is C log base 2 is nothing but 5. If depth is 64, See log log of 64 divided by log of 2 is nothing but 6. Okay. Now what are the reg data type here? Reg is clock, correct? So your inputs becomes a reg, right? Clock and reset. Again reg. We are using what? Valid and write enable. WR enable, correct? This is nothing but EN. Enable. Then what are the other reg data type are? Reg width, right? Width minus 1 colon to 0 of what? W data. Then reg address underscore width minus 1 colon to 1 0 is nothing but what? Address ADDR. These are the inputs. Then what are the outputs are? What are the outputs are? While ready, correct? Again while width, right? Width minus 1 colon to 0 of 1 or data or data that has in the module. Did you understand? Now we are doing the what? Port declaration. Inputs are ready data type, outputs are wide data type. Now what I need to do? I need to do the module instances. So what is the module name I am giving it?
सोनी पे रात
It is my module name is memory
कहाँ सोया 2 बजे सोया था मैं
and this is what? This is under PUT. Then what is the port connections are that has my clock reset. Then what I am using? Let us check my file. So this is a example, right? Address W data, address ADDR, W data, then R data, then WR underscore enable, then valid, then ready. Valid and ready. This is a module instantiation. Now next what I need to do? I need to generate the class, correct? This is depending upon the class. Generate the class. Always begin and clock is equal to 0. Let us make hash 5 times. Again clock is equal to 1 hash 5 times. Then I am going to okay. This is a clock generation after. Next what I need to do? Initial begin. To initialize the what? Reset, right? Then also read data and the write data. So initial begin. What I need to do here? Initially reset is equal to 1. When reset is equal to 1, what will happen? R data should be 0, correct? Then reset is equal to 1. We are making R data is 0. Ready is also 0. Then we are making all memory locations to 1. 0. Memory locations to 0. Then that's it, right? We have done. Then reset is equal to 1. After this, let us give some simulation time. Then what I need to do? Reset is equal to 0. Here when the reset is equal to 0, what I need to do? Now I need to generate the inputs to write the data to the memory. Correct? First we'll do how to write the memory. Then we'll see how to read from the memory. So what I need to do here? What I need to do for assigning, writing the data to the memory. Now reset is equal to 0, what will happen? When reset is 0, your valid should be 1. Valid should be 1. Then what you need to do? WR enable is equal to 1. Then ready is equal to 1. So I can write for I is equal to 0. I is less than what I can write here? Depth. Then I is equal to what? I plus 1. I plus 1. Now I am going to B. What I am doing, why I am doing here for loop? I need to write the data to what? All the addresses, right? I am iterating memory of address what the address I need to write. Did you understand? Now when I want to do this, nothing but always when I want to do is nothing but pass edge of the class. I want to do always when pass edge of the class. What I want to do? If I'm writing address is equal to what? Right? First address take what? Address of 0, address of 1, address of 2, up to so on the depth. Then what I need to do? What I want to do? W data, shall I use assign the random data to the memory? Whenever this always pass edge comes. Did you understand this? Are you clear? I'm iterating for loop I to 0, I is less than 10, then I is incremented. So always when pass edge comes, what I'm doing? Address of 1. What is the address of 1? Starting I is equal to 0, then I is equal to 1, I is equal to 2. All this, what I am doing? I am reading the data. W data is equal to what? Traversible random. Then in this case, what I want to do? What is this enable? What is the read write enable is equal to? It should be 1, right? It should be 1. Then what about read? When valid is see, this is when reset is 0. When reset is 0, read write enable is equal to 1. What we are doing? We are reading the data. In that case, we are checking the condition that valid is equal to 1. Correct? Ready is equal to what? 1. So I can make valid is equal to what? Valid is equal to 1. Now to do the handshaking, it gives some response time, right? Some time I need. Immediately, see, suppose I'm talking now. You can't immediately give the response, right? After talking to me, once you receive that, then only you can give the response to me, right? So that I need to do what? I should wait after making the hand raising. After hand raising, then I should wait to get the response from you to do the proper transaction. Then what I'm going to do? Ready is equal to 1. In this case, what? Ready is equal to 1. When this will happen? This will happen when reset is equal to 0. When reset is 0, we are taking all the address locations. For all these address locations, what we are writing? We are writing the data, W data. Then writing the data should happen when W read write enable is equal to 1. Then valid is equal to 1. Then I should wait to get the handshake. So this is for what? When reset is equal to 1. Once I write data to all these locations up to this level, then what I need to do after writing this, all the locations, then again at the pass edge of the clock, now what I need to do? All the addresses, what I need to do? Addresses to what? 0, right? So for all this depth, 0 to depth, I am assigning the what? Some random value. I'm reading to all these addresses of it. Once I complete this loop, okay? Then what I need to do? I'm using end here to finish this part. Now what I need to do? I need to do address is equal to what now? 0. Then I'm making what? W data is equal to what? W data I'm making to what? 0. Did you understand? See, the meaning is that, okay, let me write the graph here. Now this is my ADDR address. ADDR, it will start from here. 0, correct? Then up to so on here. Up to so on 31, correct? Because depth what I am giving is 32. 0 to 32, the W data should be right into the memory. It will write up to this location. Once we completing this loop, again for this what we are doing, we are making address to 0. We are making W data into what? Did you understand? W data to 0. Then we are also you can make what? What you can make? Read write enable is to what? 0. I can write read write enable to what? 0. Then what I need to do? Valid is equal to 0. I can make valid is equal to what? 0. Valid is equal to 0 for reading the. This is what I am making. Valid is equal to 1. Read is equal to 1. What I am doing? Reading the data. No. First time my focus is to how to do the read operation. So this is still it is a read operation. After this loop, once it is all this depth it is, we are assigning the what? We are reading the data. Once this loop completes, what I need to do? Now I am making what? Once this is completed, what I am doing? Address I am making to 0. Then what I am doing? W data is making to 0. Then what I am doing? W data is making to 0. What happened here? It's not 0. So what we have to tv.d. So unfortunately it is copied the other text to this one. That removes. Okay. Now this is happened when what? Reset is equal to 0. We are writing the data, then read write enable is equal to 1, valid is equal to 1, and then ready is equal to 1. Now after this loop, what I need to do? If passage comes, address is equal to, we are making address to 0. Then we are making what? W data to 0. Then what we need to do? Then we need to write enable, right? Write underscore enable to what we need to do is equal to, let us make 0. Then what I need to do? Valid. Valid is equal to 0 I make. You can understand? Then I'm going to end this. In the what? This initial begin. Still I'm doing only the writing the data. I'm not doing the read operation. Okay? Writing. Then end the initial begin. Now let us take one more initial begin. One more initial begin. Let us monitor all this line. So I'm going to do $symbol monitor. $symbol monitor. What I need to monitor here? Let us monitor the sim time. Then ASCII. Then what I need to monitor? Clock is equal to %B. Okay. Then let us monitor what? Reset is equal to %B. Then what I need to monitor? Let us write the address. Address is equal to %D. Let me print in the binary. Okay. So print in the decimal. Then W data. So it is a W data. What is the width of the W data is 60. So let us print this in the hexadecimal. So how many digits for hexadecimal in binary? 4 digits. A, suppose you are taking A, B, C, D. A is 4 digits, B is 4 digits, C is 4 digits, and D is 4 digits. Total how many? Size is nothing but 60. Let us print this in the hexadecimal. Then what I need to print? Let us print our data. Still our data we are not writing, right? We are not reading any data. Even though I am start printing. Okay. Let us write this after writing the program for what? Reading the data. Now what I need to print here? I need to print the what? Enable. So let me print the enable here. WR underscore enable is equal to what? %B. Shall I print the valid also? Valid is equal to what? %B. Then ready is equal to what? %B. This is address, this is a W data. Then what are the argument I need to pass to this? I need to pass the clock, correct? Then what? Reset. Then what is the next argument is? Enable. Then what is the next argument is? Valid. Then what I need to do? Ready. Then address. Then W data. W data. Then I'm going to end this. So let us stop this simulation. Done, right? I'm going to use dollar symbol finish. Dollar symbol finish. Then I'm going to end this initial begin. Now I'm in the model. Let us check in the end model is there. So end model. Did you understand this? So we have generated the input here. W data that will be writing into the what? Memory. So following these conditions. Correct. After this loop completes, then what we are doing? We are making all these to zeros. Then I am monitoring all these values. Okay. Now let us run for the syntax errors. Line number 42. Valid spelling of history. I am trying to writing LDN. Okay. Okay. This is valid. The end of double quotes I need to give to pass the argument I need to give the comma. Then here I am using the correct one. Valid. Okay. So valid ready address and W data. Now let us run this for the syntax errors. So register I unknown in the TB. Now let us declare the what? Integer. Okay, I am using in the test bench. Now I should declare this. Integer I. Let's copy all this. Restart this one. There is a problem in this. Now write data is happening. Write data is happening here. Did you understand this? Now let us save this file. Save all. Let us make the run.do file. This is a run.do file. So we link, vlog, vsync, not in the way. Now let us run this code. You will see the output. So still okay, I have not saved here. In the test bench, I am using what? Integer, but I have not declared this. Now let us declare the integer. Integer I. Now I am going to save all. Let us compile it again. There is a end module, unexpected end module. There are two end modules are there here. Open this file, load this. So this is the end module I am doing, this is the initial begin. Let us save and run this. So near end module there is a syntax error. Can you see what is syntax error? So initial begin and using dollar symbol finish. Which line number can you identify this? So line number 63, while passing .v file, end module, syntax error, unexpected end module, expecting the class. Huh? 24 and 60. This always begin with the clock generation at this line. Can you repeat again? Design file. Design file. Line number. Okay. This is valid spelling mistake. Says VALID, right? VALID. Now let us save all. This error I am getting is in test bench tv.v near end module. Can you go through this test bench? Is a module included name.v timescale module tv parameter input as red output as white module duty. This is according to here I am using the same one. So I am doing the order by list, port connection by order by list. This order I am using it. Clock reset address, W data, R data, read write enable, valid and read. Now I am doing the clock generation here. Always begin clock. When initial begin reset is equal to 1, then timestamp reset is equal to 0. I am doing this. I am ending this for here.
Sir, excuse me.
Yes, hello.
In DUT, we have to specify the dot clock, brackets clock like that. No? Here, no need of that.
Oh, you can do also. Port by name connection also you can do. But what connection I am doing here? Port by order list. This also
Order,
fine.
okay.
The order which are mentioned in the design file, same I am mentioning here. This is the for I am ending here. And this is end for what? This initial begin. Now I am using initial begin $symbol monitor. So I am monitoring the clock reset enable